Good morning, sir. I'm Kevanilla. I'm from CSC Department of AML. My roll number is 25955586626. Today, my topic is livestock market dashboard. Introduction to livestock market dashboards. That a livestock market dashboard is a real-time web application that displays the data such as stock prices, trading volumes, and market indices. It enables investors and analysts to monitor market movements, make informed decisions, and respond quickly to the changing conditions. These dashboards integrate data from financial APIs, process it in real time, and present it through interactive visualizations. The common features include price charts, watch lists, new feeds, and technical indicators like moving averages. And building such a system involves front end design, back end data processing, and real time communication technologies. This is the introduction to the livestock market dashboards. That it is a real time web applications that used to represent the data, such as in the form of stock prices, trading volumes, and the market indices. And it makes the informed decisions and it responds quickly to the changing conditions in the market. And these dashboards integrate the data from financial APIs, and these include the price charts, watch lists, and the news feeds. Next, and the system architecture overview. The architecture typically follows a three-tier model: that front end, back end, and data sources, that UI server and the APIs. The front end uses framework like React or Vue.js to render dynamic charts and the user interfaces. The back end, that built with Node.js or Python, handles data fetching, processing, and the user authentication. The real-time updates are delivered via WebSockets or server-sent events, that SSE, that to avoid constant that HTTP, that's hypertext transfer protocol polling, and the data is often cached using Redis to reduce API call frequency and improve response times. This is the system architecture overview of the market. That it The architecture typically follows the three-tier model, that is front end, back end, and the data sources. The front end uses the React frameworks like React or Vue.js, and the back end uses the Node.js or Python, and the real-time updates are delivered via WebSockets. And data sources and APIs. The financial data is sourced from APIs like Alpha Vantage, Yahoo Finances, and the cloud, that which provide real-time and historical stock data. The APIs return structured data in JSON format, including fields like symbol, price, volume, and timestamp. The rate limiting is a common constraint requiring efficient request scheduling and caching strategies. The WebSocket API's example Polygon IO, that enables streaming of live ticker updates for real-time dashboards. And the authentication via API keys ensures secure access and usage tracking per user or application. These are the data sources for the marketing architecture, that uses APIs. That financial data is sourced from the APIs, and the APIs retain the structured data in JSON format, and the rate limiting is common constraint, and the WebSocket APIs enable streaming of live ticker, and the authentication via APIs keys ensure secure to the market sources. And next, front-end technologies and design. The modern front-end frameworks like React enable component-based UI developed for modular and reusable dashboard elements. Charting libraries such as Chart.js, D3.js, or Apex Charts render interactive time series graphs, and Candlestack charts responses design ensures the dashboard works seamlessly across the desktops, tablets, and mobile devices. And the state management tools like Redux or Context API help manage user preferences, watch lists, and the real-time data updates. And the UI UX principles emphasize the clarity, minimalism, and intuitive navigation to support quick decision making. This is the front-end technologies and designs that are used for the marketing architecture, and these the modern front-end frameworks like React enable component-based UI and the chart libraries such as Chart.js and D3.js or these are series graphs, and the responsive design ensures the dashboards, and the UI UX principles emphasize the clarity and it maintains the minimalism, and it emphasizes the intuitive navigation to support quick decision makings. These are the front-end technologies and designs. And next, backend development and data processing. The backend server fetches data from financial APIs, processes it, and the servlets that the front end via our REST or WebSocket endpoints. The Python with Flask or Django is commonly used due to its strong ecosystem for data handling and web services. The data normalization ensures consistency across different API responses, eh, especially when merging resources. The data normalization ensures the consistency for the APIs and the schedule tasks like example using Celery or cron jobs that periodically update historical data and refresh caches. The error handling and retry mechanisms are essential to manage API failures or networks issues gracefully. This is the backend development of the market architecture and the data processing that fetches the data from financial APIs and processes it to the front end, and the data normalization ensures consistency, and the scheduled task periodically update the historical data and refresh caches. The error handling and retry mechanisms are essential. This is the backend development and data processing. The real-time data streaming is that the WebSockets provide full duplex communication, allowing the server to push the updates to connected clients instantly. And the libraries like Socket.io simplify WebSocket implementation with fallback options for old browsers. And the connection management includes handling reconnections, timeouts, and scaling across multiple server instances. Each client subscribes to the specific stock symbols, and the server broadcasts updates only to relevant users. And the database design and caching. A relational database like PostgreSQL stores user accounts, watch lists, and historical preferences. And the time series databases such as InfluxDB are ideal for storing high frequency stock price data efficiently. And the caching reduces load on external APIs and accelerates data retrieval for real time displays. The database indexing on timestamp and symbol fields ensures fast querying of historical trends. This is the database design and caching that database like PostgreSQL store the user accounts, and the time series database such as Influx are ideal for storing high frequency stock, and the caching reduces load on external APIs and accelerate data retrieval for real-time displays. Next, security and authentication. The user authentication is implemented using JWT, that JSON Web Tokens or OAU, for secure access controls. The HTTPS encryption protects data in transit between client server and third-party APIs. API keys are stored securely using environment variables or secret management tools like HashiCorp or Vault. The rate limiting and IP whitelisting prevent abuse and protect against DDoS attacks. The input validation and sanitization guard against the injection attacks and malformed requests. Next, data visualization techniques. Line charts display stock price trends over time, while candlestick charts show the open, high, low, and close values. The bar charts visualize trading volume, helping identify periods of high market activity. The color coding example green for gains, red for losses, enhances readability and quick interpretation. The interactive tooltips and zoom features allow users to explore specific time ranges and data points. This is a data visualization technique. And performance optimization strategies are debouncing and throttling limit the frequency of API calls and UI updates during rapid price changes. And the data aggregation reduces granularity for long-term views that example daily instead of minute level data. And the front-end code splitting and back-end microservices improve scalability and maintainability. Monitoring tools like Parameters and Grafana track system performance and detect bottlenecks. This is the performance optimization strategies. And next, scalability and deployment. The containerization with Docker ensures consistent deployment across the testing and production environments. Cloud platforms such as AWS, Azure, or Google Cloud provide scalable infrastructure and managed services. The CI/CD pipelines automate testing and deployment, enabling rapid iteration and reliable releases. This is the scalability and deployment. And next case study is that building a minimal viable dashboard that start with a simple React front-end displaying real-time prices for a few stock like Chart.js, and it implement WebSocket support with socket.io to push live updates every 5 seconds, and deploy the app on Heroku or AWS EC2 with environment-based configuration for API keys. The store user watch list in PostgreSQL and catch current prices in Redis for faster access. Challenges and future enhancements are that handling high frequency data streams require efficient memory and CPU management to avoid lag, and the personalization features like alerts, portfolio tracking, and AI driven insights can enhance user engagement, and ensuring compliance with the financial regulations, example, data licensing, is crucial for the real world deployment. These are the challenges and future enhancements. Thank you, sir.